Hello everyone, this is Andrew Gluck. This is my presentation for Predict 413 midterm. I'm old school, so I still call it Predict 413, but this is the approach I took for the project. So as we all know, the objective is to predict total sales for every product from one of the largest Russian software firms over the next month. So I started by doing some basic EDA, just looking at the structure of the primary data sets, the training data set, and the test data set. We have over 2.9 million rows in the training data set, 9 variables. We see that in that item count data that we have some negative numbers there that are nonsensical, and I'll be getting rid of those for my analysis, as well as any NA values. We see for this test, the test set, 214,000 rows, and that's ultimately what we'll be using for the Kaggle submission is the test set. I did a decomposition just to see if there was seasonality or any trend components that were noteworthy, and there's clear seasonality and clearly a downward trend. That graph on the right really doesn't give me a whole lot more information value. It just takes out the seasonality, so that's really just trend plus error, but obviously declining sales here. Here's a GG plot I created of seasonality and trend, again just showing that both exist. We see that the peaks are at the end of the year, so likely for holiday shopping, Christmas or Hanukkah shopping, but we do see that those peaks, the peak in 2014, for example, is much lower than in 2013. This is just another representation of that same data. By the way, I did find some useful information on the kernels part of the Kaggle website, so some of this code is taken from that. I created the code myself, recreated it, but just for full disclosure, I did find some information value there. Now, one of the graphs I found really interesting was this one, and it shows that January sales and December sales are pretty similar here. They're sales by month. What it doesn't reflect is that this data only goes through October of 2015, so the December sales here is only 2 years of data, and the January sales is 3 years. So this is misleading. So as analysts, we need to be really careful about how we present our data and making sure that we're at least transparent as to what's being reflected. The other thing, I'm still curious that the sales in January are as high as they are. What I'm not sure is if this data is gross sales or net sales, because I could see a lot of people returning their gifts that they received in December, returning them in January, and then perhaps buying something else. That new purchase may be counted as a new sale, even though it was due to them returning something. So the gross sales may increase while the net sales actually stays flat. So as an analyst, I would want to understand that better. So I deconstructed 2013, 2014, and 2015 sales so I could see exactly what was going on. Again, there you can see in the blue is 2015. You can see that the data doesn't go through December, back to my point on the previous slide. Not surprisingly, weekend sales are highest, Saturday being the best-selling day. Again, as an analyst, we would want to know if there are 4 Saturdays in a month or 5 Saturdays in a month, as far as forecasting and just indexing that to take that into account. Here are some outliers, some clear outliers there to the right. I'm going to clean those up to make sure that there aren't any leverage points in the data. So take out some of those outliers. 10% of the categories comprise 66% of items sold, so chances are we could take out a fair number of those categories and still have a representative sample to do an analysis with an easier, not so unwieldy data set. Same thing as far as total sales by item. There are 21,000, almost 22,000 items. Roughly 50% of them fall into the top 5 categories, so perhaps some cleanup can be done, making the analysis easier, but also not compromising the data too much. I chose an ETS model. Here you can see the versus AutoArima, the AIC numbers are pretty similar, but the RMSE is far lower in the ETS model compared to auto-ARIMA. So that was something that gave me some comfort in using the ETS approach. And this is something I found online. It's a Hindman PowerPoint, but that last bullet point, the ETS framework provides an automatic way of selecting the best method. It was developed to solve the problem of automatically forecasting pharmaceutical sales across thousands of products. So that resonated with me as to what we're being asked to do in this assignment, and that is the direction I'm going. So that's what I have right now. Still a lot more work to do. Good luck to everyone, and thanks for watching.